Hello, I'm Roman, and welcome back to the series of videos Neural Networks from Scratch in Golang, where we using this book called Neural Networks from Scratch in Python, but we writing everything with the Golang. And I want to remind that I created a Discord channel so you can connect, and you will find links in on the channel, in the video description, and in the pinned comment. So you're always welcome to the server so we can discuss various things around the tech industry, coding, and maybe some fun part. And in the previous video, I almost, well, I continued to build the model objects. And in the previous video, I finished, well, this part. And right now I need to prepare data for, what is it? I need to prepare the data for binary logistic regression model. And we go in with this thing. And the interesting part is we need to reshape labels to be list of the lists. Inner list contains one output, either 0, 1 per each, 1 in this case. And I think that's the general approach for, it's called, for the data that I will need to use, since I'm changing the way I generating and storing the data as the binary logistics, well, at the dense class. So we're going to fix the spiral data first. And where is it? Spiral data, because currently it returns, yeah, I have to do fix y. Currently it returns array of unsigned integer, one dimensional, but I need to return another dense. And you might be wondering why. So in this case, y will be actually met new dense by the number of the samples multiplied by number of the classes with one column, and we need to allocate this. So then we need to actually y set I, j, and that's class number. And that's it, right? Actually, how it was? Wait. No. Ix. Okay, so I have only one column. I'm going to insert into the ix. Okay, that's the thing. So that will return to me spiral data, where I have rows, well, where each row will represent the sample data, and in the next one, in the y, in the target, each row will represent, it will represent one-dimensional array with one item, and it will represent the output class, right? So then then I'm going to fix this one. I probably just, delete inside this, and I will start from scratch. I think that's the best approach I can do. So what I can do? So I have the x and y equal to dataset spiral data by 200, 100 samples for the for the two classes, because we're going to make the binary regression model. And I have the same validation and validation, right? Okay. I don't need to reshape it because it's already in this way. Because the way it was implemented here, for the X, it returns a two-dimensional array, and for the Y, it returns one-dimensional array. So it was basically a list. And in order to match this logic, I just told you that kind of row always represent the samples. And, you have this match. For example, I want to check the data for tens sample and what was the output. So I can, subscribe with X tens row. It will return me a list of the values for the input data. And the same if I will do Y from subscripting 10, it will return me the list that will contain one value with the result class. So then we're going to create the model, which will be model, right? And I don't think I need to allocate something in first place. Then what I need to do, I need to add the layers. And the interesting part is how I will define the regolizer. Okay, so what I'm thinking, I will create the layer 1 as separate layer, this one, right? So then I have layer 1 initialization. I have number of inputs 2 and I have number of neurons 64, right? Then I want to assign which one? L2, and that will be what's called init. No, not this, and that will be weight as 5e minus 4 and bias 5e minus 4. Can I do this? No? Okay. That's L2 regolizer. Okay. Layer, right? So what then we do? It's called adds and we pass the first layer. Okay, then it should be easier because we're going to create layer, but what's the act? Oh, it's actually the activation relu, right? Then we add in second layer, which is the layer dots layer, and we do this trick with the initialization 64 by 1. Cannot call pointer. Yes. I think that should be like this. Yeah. We had the second layer and we had adding the activation sigmoid, right? And then we need to create loss binary cross-entropy loss. Okay. Okay. Loss will be loss binary cross-entropy loss. Then we have the optimizer, which is the optimizer new atom, right? We changing the decay to 5 minus 5e minus 7. Okay. And we creating the accuracy object. So that will be accuracy. categorical accuracy, I think, right? And what do? We call set and we pass loss, optimizer, and accuracy. Okay, loss, optimizer, and accuracy. Binary percentage loss doesn't implement loss interface. Okay, what is missing? Let's start changing it. Well, first, to please the compiler, let's do this, right? That should please the compiler, right? What else? Missing get the inputs, okay. And func loss binary gets the inputs. Math sense, return loss. Okay. Then we call model finalize and model train. Right now we need to create the model data x and y, but it's be x, y, number of epochs in the same, and we need to have the validation data, which will be x validation and y. Continuous y val. Continuous y. Okay. Okay, actually it seems that's okay. What is it? Okay, maintenance. Okay. I will run, but it should not work. Models category. Wait. Categorical, and I will do the same. I will comment it for now because I don't want to get rid of this and I don't want to fix it now. It's working. The interesting part is that the regularization loss is always 0, which is weird. Okay, but let's compare the results. I'm not sure. Well, the accuracy is correct. Okay, nice. Yeah, it should have the regularization loss, and I have too many high accuracy. I just think that the accuracy is not correctly calculated. But let's try these parts. Main. Okay, I have it has layers. For example, first layer should have L1. No, it hadn't. But this is okay. Okay, so L2 regularization is always 0. And maybe actually That's the problem. Mhm. So what we have? Um, mhm. So it's not saved. Okay, let's go to where run binary. But here I store it, right? So okay, that's from the run. Why? Mhm. Yeah, because from what I see, the first one has no. Okay, let's restart. Maybe that's the issue, which shouldn't be. Run binary. Okay, let's test this one. Okay. We have the data set, we have the model. Yeah, I mean, yeah. Yeah, I've been just testing the different model. Okay. Okay, so let's test. It shouldn't work, right? No, it works. Interesting how fast it was. Okay, I have the low loss value. I don't have. Why don't? Oh, this is the validation. I have the loss and I have the accuracy. The accuracy is less than during the training, so we overfitting most likely, but yeah, that's the same problem here. High. I'm surprised it works from the beginning, but I will remove it. I mean, I still have these to-dos, right? I still have this issue with copying of data. Fix target path. Do I still need it? Yeah, that's a good question. Fix target path. Yes. Fix. Yeah, that's when we will get back to the categorical model. This is, I have no idea what is the warning. Okay, let's take a look at what is happening here. Okay, so we have layers and I mean, I think I should read this part of the goal, but from if I no treating the syntax correctly, and if I wrote it correctly, so the layers in my case is the array of references, and I want to store it as an array of references. And for example, the zeros. Yes. So for example, this I'm not sure mm, how it goes. It goes from set layers past trainable layers from finalize, right? And if we check it, so right now the loss main layers. should have the reference to the same struct. But the inputs is the weights, the biases. But okay. Okay, so this one goes from the train. Okay, it actually has some values. It doesn't have the d weights, the biases, and the d inputs because I think that's the first pass. Oh, okay. And yeah, it created some of the values. So, but I still confused. Okay, wait. I don't understand. Before there were a warning, like something like unused assign or something like this. Okay. Now that we're streaming the forward and backward pass code, including the validation, this is a good time to reintroduce dropout. Recall that dropout is a method to disable filter out certain neurons in an attempt to regularize and improve our model's ability to generalize. If dropout is employed in our model, we want to make sure to leave it out when performing validation inference. In our previous code, we left it by not calling its forward method during the forward as during the validation. Here we have a common method for performing a forward path for both training and validation, so we need a different approach to turning off the dropout to inform the layers if we during the training and let them decide on the calculation. I think we can, just pass the parameter into the forward, and then we can check if the layer is actually it actually makes the forward and backward path a little bit more complicated because we could have several dropout layers and we need to all of them skip. But yeah, the first we'll need to introduce the training boolean. Okay, let's see. What I want to do is okay, that's fixed. Okay, this one and making binary model. If not training, in all layers of activation classes, since we're calling them in unified form. Yeah, I mean, okay. Layer interface I should have and inputs training. So, well, first is training and it should be bool. And right now I should have, yes, I should have errors because, for example, here that should be is training pool, right? In the dropouts, I should have the same is training pool. In the input layer, I should do the same, although, well, okay, is training pool. Okay, let me copy this because I need to do the same for all of the activations since they here, yes, here forwards here Then we go in here, then this one, insert, softmax, forward, and here. Why do I still have the error in the model? Not enough. Okay. But I think that should be the same, right? And is training and is training. And same here. Forward. We are in the training, so we pass in true. And here we are not in the training. Make builds. Okay. Right now, then I need to change the dropout layer. Okay, and what they suggest. When we are not training, we can set the output to the input. We can set the output to the input directly in the layer dropout class and return from the method without changing the output. So, okay. So we're saving the inputs. If not in the training, we just return the values. Okay, so if not in the training mode, that I guess if not, if is training, if it's not training, right? What we do layer output, we then making the copy of the inputs and we return. Okay. What it means, yeah, then we, if not, we generate all of the things, and that's already implemented. Next, we modify the forward method for our model cast to the training parameter and call to forward method, blah, blah, blah. That's, I already did this. And yeah, we need to update train methods in the model class since training, blah, blah, blah. Okay, making the full train method in the model class. Training, not train. Yep. The last thing we have to. Oh, okay. So it will call the forward method, but it will just pass the data based on the flag. Oh, okay, it's actually not that hard. Okay. The last thing that we have to take care of with the model class is the combined softmax activation and cross entropy loss class that we created for faster gradient calculation. The challenge here is that previously we have been defined forward and backward pass by hand for every model separately. Now, however, we have loops over layers in both directions, calculations, a unified way of calculating outputs and gradients, and other improvements. We cannot just simply remove the softmax activation and cross entropy loss and replace them with an object combining both. That's true. It won't work with the code that we have so far since we are handling the output activation function and the loss in a separate way. Since the combined object contains just a backward pass optimization, let's leave the forward path as it is using separate softmax activation and the category cross entropy loss objects and handle just for the backward. Really? To start, we want to automatically decide if the current model is a classifier and if it uses the softmax activation and the category cross entropy loss. This can be achieved by checking the class name of the last layer's object, which is an activation function object, by checking the class name of the last one. We'll add the check. I mean, this is. I mean, I'm not glad that I had to do the downcast, but this is the. I mean, this is not good because the model I mean, the idea of having the general classes and splitting the classes of the model will kind of operate on the high level thing, but currently we, adding a very concrete edge case here. So we're checking if it's a softmax, create an object of combine activation and loss. So it will have a specific field for the softmax classifier output. To make this check, we're using Python's isInstance function, which return true if a given object is an instance of the given class. If both of the tests return true, we're setting a new property. Also want to initialize this property with the value of none in the model class constructor. The last step is during the backward pass to check if this object is set, and if it is, to use it to do. So we need to handle this case separately with a slightly modified version of the current code of the backward pass. First, we call backward method of the combined object. Then, since we won't call the backward method of the activation function, last object set the deep inputs of this function with the gradient calculated with the activation. At the end, we can iterate all of the layers except for the last. So if it's a softmax classifier, first call backward method on the combine activation loss. This will set the inputs properly. Since we will not call backward method of the last area, which is softmax activation, as we used combined activation loss object, let's set the inputs in this object. Call the backward, and then call the backward method going through all the options, but last in reverse order, passing the inputs as the parameter. How it looks like. Okay, so that's the creation. Where this piece of the code, how it looks like. I don't like it, and I don't want to implement it in this way, as we won't need the initializer and the forward method of this anymore. We can remove them and then just the backward path. Now we can test our updated model object with the dropout. Set the loss. Seems like everything worked as intended. Now that we have the models, we're able to define new models without writing large amount of code repeatedly. Writing code is annoying and leaves more room to full code at this moment. So I guess that's the end of the chapter, right? Let me check. Yes, that's the end of the chapter. And I don't want to implement it in this way. Of course, I can do this. I can do this downcast, very specific, and I can write this. But I mean, I need to think, and probably I will stop recording for today. And yeah, it will be just short because I want to start the next video with an understanding how to write. Okay, on the other hand, I still can ignore this optimization and I will just use activation softmax and categorical cross entropy loss, and that's it. And the problem with this that chain calculation of the softmax and the loss takes much longer than this combined version. And in general, having the optimization is a good thing, but this one I need to think how to. Maybe I can implement this object in a way that it will follow both no, mm, both interfaces, like the layers and the loss interface. And the tricky part will be to implement it in a way that the forward and the backward method calls for each of these objects. So we need, I know, some counter, or yeah, I mean, it still will be a little bit messy codes, but yeah, actually, if you ever wrote any hard optimization, they always look some piece of the crap, but they usually optimize a lot of the things. So, but I don't want to mess with the model class. I want to model be as generic as it possible, and we will move this, bad bad code into this object. Maybe, yeah, maybe an idea is to actually follow two follow two interfaces and implement them both, and then think how, maybe count the number of the calls to understand, for example, right now we're calling it as a soft, as the activation function, then as a loss, something like this. Yeah, I will check the code once again, and I will prepare the plan how to do this. So I'm not going to spend that much time, thinking silently and implementing later. So, but I implemented the binary model. It works, but actually, yeah, the accuracy calculation that I wrote, this one, and I mean the loss activation, like the mean squaring error and the thing, they won't work for the categorical with the way it was implemented before. So I still need to fix this. So I'm not sure that I will finish all of these things in the next video, because I have some leftovers too before we can go. And the next chapter is called real dataset. So I would like to fix all of the problems that I have before I go into test the code on the real dataset. Another reminder, I have Discord server. Don't forget to check it. Don't forget that I have the main channel where I do post some token head videos, and one of the last videos I have is why I switched to NeoVim in the coding. So you can find ideas and reasons why you might do this, or maybe not. Don't forget to check. All the links will be down below. Thank you for watching, and I see you tomorrow. Bye bye.